Now let's set up the simulation conditions in earnest. You can define the structure information for the 3D structure. Add or delete layers using the icons at the bottom. So to add a layer, click Add button and enter the name and select the material type. In this case, I will enter glass and select insulator. Click OK button. You can see that the glass layer is added. This green icon is called zone condition, and you can define the properties of the layer in detail. It consists of 3 tabs: General, Material, and Advanced. I will explain the basic features that you need to know for using the TRCX program. The Advanced tab is for creating a realistic layer structure. Please check the manual for descriptions and usage about Advanced tab. And from now on, I will talk about the General tab. You can modify the layer name and material type between insulator and metal. And select the substrate property. If the layer is stacked, select stack. If the layer is a substrate like the glass layer, select substrate. If the material is being filled like LC, select fill. And please note that the displayed UI varies depending on the substrate property. And also you can define the thickness. And there are division and division left zone. They are activated when measure type is set to tapered. Division means the number of divisions in the z-axis direction. You can clearly check the difference in the layer structure created when division enters 10 and 1. The division left zone is an advanced option related to the planarization, so I will skip it. The next one is planarization. To generate the planarized layer, please check this option. The degree of planarization and gap position are also activated. The degree of planarization for the layer varies from the entered value. So this figure shows whether the planarization option is used or not. As an example, when the degree of planarization is close to 1, the structure will be perfectly planarized. On the other hand, when the value is 0, the result is the same as not using this function. The conformer structure is generated. In the gap position, set the position where the planarization option is applied. And there are 5 types: mean, max, relative position, estimating position, and keep sidewall. Since usually mean and max options are used, I will mention them. Literally, mean means that defines the thickness based on the minimum position, and max is based on the maximum position. if the gap position is selected as min or max, the reference zone is activated. The entered thickness is determined based on the layer selected in the reference zone. The following example is easy to understand about the concept of the reference zone. At first, let's check the simulation conditions of layer C. The thickness is 1 micrometer. Set DOP as 1 to completely planarize, and the gap position is max. On the left, the reference zone of layer C is set to none, and on the right, the reference zone is set to A. By the way, did you see the difference between the two figures? On the left, the thickness of layer C is defined based on the max position of layer B, because layer B is just below layer C. On the other hand, for the second one, the thickness is 1 based on the top of layer A, because the reference zone is set to A. And the next one is an electrode naming layer. If users already defined the electrode names in the layout file like this, just select the layer number that defines the electrode name as text format. And the port is composed of 3 types. Port naming layer means an edge port. Top or bottom port means a sheet port like a polygon type. Choose the mask layer number that defines the port name as text format. Even if the port name is not specified by the user, it can be automatically assigned when it satisfied the algorithm of TRCX itself. Special conditions are as follows. Condition 1. The boundary of the simulation area and electrode should be in contact each other. Condition 2. The electrode should be transverse electrode penetrating the simulation area vertically or horizontally. One you need to know is that the port names set by the user always takes precedence. And here is an example. In this case, port names are not defined by the user, and it satisfies the condition 1 and 2. Therefore, the port names EU and ED are automatically assigned by the rule. The rule is that electrode name / U or D or L or R. It means that up, down, left, and right. In the patterning property, define the mask of the layer. Select the mask that matches the layer. And if the mask is a negative mask, please check it. Choose the sidewall type among 6 taper models. In the taper type, select one between angle and width. Depending on the taper type selection, the input value is set as angle or width for the taper value. Finally, edge part. Let's see unselective edge and edge stopper first. Unselective edge means that the etching process starts from that layer. Then, Etching proceeds until just before the layer for which the etch stopper is checked. To clarify the concept of unselective etch and etch stopper, let's look at the following example. The etching process starts from layer 3. So, in the zone condition of layer 3, the unselective etch should be checked. And after that, the until zone at the bottom is also activated. Basically, when using the unselective etch, until zone should be set as none. And when you want to proceed with the etching process from layer 3 to layer 1, layer 0 is an etch stopper because etching proceeds until just before the layer for which the etch stopper is checked. There are several notes for using these two functions. Electrical connection between layers is very important in RC calculation. Therefore, the purpose of the layer to be used for unselective etch should always be set to contacts. An etch stopper is applied automatically when set under certain conditions. Purpose is active or color filter. Type is metal, and substrate is set to substrate or fill. So please remember these precautions. The next one is until zone. It is convenient to think of until zone function as a slightly more powerful etching process. Even if there is a layer set as an etch stopper between the layer designated as until zone, the etching process is unconditionally performed. This example is easy to understand about unselective etch and until zone. In the case of unselective etch, if the type is metal, the etch stopper is automatically applied, and for the deep blue layer and purple layer, the etch stopper was specified by the user. So, the etching process was performed just before the metal layer. On the other hand, if this blue layer is selected in the until zone, whether there is a metal layer or etch stopper layers, the etching process proceeds until just before the blue layer. So, this is the difference between unselective etch and until zone. There are two other functions in the etch part, overetch thickness and CMP thickness. By using overetch thickness, it is possible to generate a structure that is overetched as much as the entered thickness. The next one is CMP thickness. CMP stands for chemical mechanical polishing. Just enter the thickness to proceed with the CMP process. These two functions are only activated when the measure type is set to tapered in the mesh tab. So, we have checked all of the functions in the general tab, which is the most important concept in the zone condition. Let's move on to the next tab, material. Depending on the type between metal and insulator, the displayed material item is different. For example, for insulator, dielectric constant is displayed. For metal, resistivity and sheet resistance are displayed. And the next one is Advanced tab. There are a lot of functions such as doping, step coverage, and change zone material. Also, if you click the list at the bottom, you can add functions such as change material and junction. For detailed information on them, please refer to the manual. Now that we know about the zone condition briefly, let's define the stack information of the OLED pixel example. First, add the layers to be used and define the name and type at the bottom. To modify the material information and thickness, just double-click it or click zone condition and you can change the thickness and material information. For me, I will just double-click it and change the value. Let's check the layer at the bottom step by step. Since it is a bottom substrate, substrate type should be changed as substrate. And then click OK button. The two buffer layers will be skipped because there is any other modification. The next one is the active layer. First of all, active is the layer to which you need to specify a patterning mask. So, select the active mask in the patterning part. And the doping option should be applied as well. Doping option exists in the Advanced tab. Here is a doping option. Except for the area where the active and gate layers are overlapped, like these parts, the remained active layer is changed to metal. The method to use it is as follows. First, select the gate mask in the mask item, and you can also modify the values of diffusion, resistivity, and sheet resistance. I will talk about the submask later on. So, the difference in the doped area according to the diffusion value is as follows. If a value greater than 0 is entered, the doped area is expanded. And let's take a look at the following example together. It is related to the submask. Active and gate layers are as follows. As you can see, the number of overlapped areas is 1, 2, 3. Total 3. If the active layer is stopped, the active areas are metallized except for the overlapped area. So total 4 separate electrodes are created. However, if you draw 2 of the 3 overlapped areas in a box shape, like this, and designated it as a submask, the result is like this. Even if the active and gate layers are overlapped, the area is designated as a submask. Therefore, this region is doped like this. Go back to the zone condition and let's define the doping option. First, select the mask with gate purpose and enter the resistivity as 0.05. For other options, I will just use the default. Click OK button. And let's check the active mask layer. Since the areas are metallized according to the doping condition, I already defined the electrode names as text form in advance. Therefore, it is necessary to set the electrode naming layer as well. This information can be checked by str file after structure generation. For the intermediate insulator layers, I will skip them. And let's define gate 1 and gate 2. You can see that each gate layer has a patterning mask and electrode names. Therefore, just select the patterning mask and electrode naming layer. The next one is the contact hole mask. If you check the layout, the CNT mask is a hole-shaped mask. In order to create a hole structure, this mask type is negative, not positive. Click the zone condition and define the patterning mask as CNT. Please check the negative option. The role of the CNT layer is to connect electrically between SD and active layers. It means that the layers in between should be applied the etching process. Once again, I will give you the definition of unselective etch and etch stopper. If unselective etch is checked, the etching process starts from that layer. Then etching proceeds until just before the layer for which the etch stopper is checked. Therefore, unselective etch should be applied to the CNT layer, and for these three insulator layers, the etch stopper should be unchecked. So I will check the unselective etch for the CNT layer. And for these three insulator layers, I will uncheck the etch stopper. Also, I already mentioned that the purpose of the layer to be used for unselective etch should always be set to contact. So, let's click the Set Technology and check the purpose of the CNT. It is contact, so it's okay. So let's check later if the structure is generated the way we want it to. The next one is the SD layer. Let's check the mask first. Unlike other metal layers, the SD mask has no defined electrode names. In this way, users should define the electrode names, but the layout file is saved without defining them before. Through TRCX, it is possible to specify the undefined electrode names. Users can define the electrode names while checking the connection between the electrodes. If you click this RC tab, there is an undefined electrodes. I will explain how to define it in detail later on. So, for the SD layer, just select the patterning mask. And the following one is a via hole. If you check the layout, a via mask is also a hole-shaped mask like CNT. Therefore, this mask is negative, not positive. Click the zone condition and define the patterning mask as via. Please check the negative option. Since the role of the via hole is to connect electrically between anode and TFT underneath. Therefore, unselective etch should be checked as well. Additionally, it is a very thick and planarized layer. So, check the planarization, and to completely planarize, enter the DOP as 1. For gap position, select max so that the planarization option is applied based on the highest position of the bottom layer, SD. And then click OK button. The next one is the anode layer. Define the mask and set the electrode naming layer. And the next one is PDL. The purpose of using the pixel define layer, which is called PDL, is to divide the subpixel area clearly. Therefore, since this layer also uses a negative mask, please check the negative option. And to completely planarize, check the planarization and enter the DOP as 1. And for gap position, select max so that the planarization option is applied based on the highest position of the bottom layer. And for the EL layer, there is no mask, and I want to planarize completely at the highest position based on the anode layer here. Therefore, check the planarization and enter the DOP as 1, and then gap position should be set as max. In this time, the reference zone is anode. So from now on, we defined the properties of all layers to be used.